Good afternoon, everybody. Welcome to the free informational session jointly presented by the Occupational Hygiene Association of Ontario and the Canadian Aerosol Transmission Coalition. Our presentation today is Mask Smart 3, Protecting Workers from Airborne Hazards. My name is Landis-Groom. I'm the immediate past president of the Occupational Hygiene Association, and I'm delighted to have everyone here today in our roster of experts to continue the conversation about respiratory protection programs and the demands therein. So we all know that the pandemic has brought personal protective equipment to the public eye, and effective transmission reduction requires a consistent respiratory protection program, plus ongoing attention to matching the device choice to function, ensuring proper fit. Now, if these can be all new, daunting concepts for many workplaces who historically have not required to have a respiratory protection program. So professional occupational hygienists and members of the Canadian Aerosol Transmission Coalition would like to help workers and workplaces gain a practical understanding of respiratory protection programs and the demands within them, when they're needed, how to get started, where to go for more information. So today's session is going to focus on how to select a respirator, the basics of a respirator fit check, and then some lessons learned from those experts in the field. This session is, like I mentioned, intended for those who historically have not required respiratory protection programs in the past. So this may be employers, workers, Joint Health and Safety Committee members, health and safety reps, or those who just wish to have a refresher of some of the concepts. In terms of questions, please enter them in the Q&A box, and they will be addressed at the end of the session. And now I would like to introduce my co-moderator, Kevin Hedges.
Thanks very much, Anne-Marie, and good afternoon, everybody. It's really fantastic that you can join us on this webinar. I'm actually representing the Canadian Aerosol Transmission Coalition. I'm the past president of Workplace Health Without Borders International, which is a coalition member. The Canadian Aerosol Transmission Coalition truly is, it's an interdisciplinary, multidisciplinary group involving engineers and medical doctors. So it's just a great group that can share information. And OHAO is also a member as well. But just before I move on to business, I just want to acknowledge the First Peoples and traditional territory. I'm actually based in Ottawa, so I just want to acknowledge respectfully in Ottawa the Algonquin and Anishinaabe people as well. And this is Mask Smart 3, and I'll put a link in the chat box for both Workplace Health Without Borders, actually, because many on the call might be interested in joining, and also the coalition website where two of the previous webinars have been recorded. So if you haven't seen them, go back and watch them. So the last webinar we had Kashif Prasada, a medical doctor, and Paul Bozak, who everybody will know here, and we also had Neil McDermott. So, you know, we talked about why masks still matter, what is a respiratory protection program, and respiratory protection programs, top 10 lessons learned. So this is kind of like the third webinar, Mask Smart 3. And the first speaker is Dr. Simon Smith. So Dr. Simon Smith has an amazing experience in respiratory protection. He's so generous with his time. We got to know Dr. Smith through Workplace Health Without Borders, and he's supposed to be retired, but he just keeps donating his time. And He's supposed to be retired for nearly 3 years from a senior research role at 3M Canada. He's got over 35 experience in respiratory protection filter development. Career roles have included establishing and leading a respirator filter research and testing center and developing products for worldwide application in the fields of healthcare, industrial, military, and first response. Simon has participated in standards development in respiratory protection since 2005. So if you have a look at 94.4, the Canadian standard for respiratory protection, for protective equipment, there's a section in there on bioaerosols using a controlled banning approach. Simon actually led that section of the standard as well. There's also another standard which Simon will probably talk about, 94.4.1, around specifications. He's also contributed to several industry organizations, committees, including the International Society for Respiratory Protection. I think he was actually chair at one stage, and American Industrial Hygiene Association, and the US National Academies of Science, Engineering, and Medicine. So thanks again, Simon, over to you.
Thank you. Thank you very much indeed. I hope everyone can hear me. I
Yes.
apologize. Just at the last minute, my internet switched off and I missed most of the introduction, but thanks very much anyway. I'm just going to try to share a screen and we'll show some slides around the aspects of selection, use and care of respirators. And being aware that this is a presentation to people who probably overall have not historically had to be involved in respirator programs. Of course, the public over the course of the pandemic has become remarkably, perhaps unwelcomely familiar with respiratory protection needs. And we've been hearing from some people, oh, you know, respirators are new. Well, the fact is that respirators aren't new to the world, even if a lot of people are new to using them. World War I involved the use of gas, and that really led to great advances in respiratory protection technology. And so we have more than 100 years of history in this. Industry has been using various kinds of respirators, again, over time. Perhaps from the 70s onwards, we've seen the documentation of legislation, performance standards, and a compilation of certification programs, originally from mining aspects, that then brought into all industry, so that we have now a system where performance selection and usage has got a very strong backing of technology programs and practices. And we have a very good system that, with legislation combined with standards, ensures that where needed, high capability equipment is available for workers in Ontario and Canadian workplaces. And really this applies in many of the developed countries in the world as well. So great to say, some people are saying, oh, there's a lot of new technology. It's not really that new. It's been around for a while. We've had industry using them. We've had test facilities, and we have standards, specifications addressing both selection and performance. I'll be talking a bit about selection in this presentation. And just to cover a few things up front, I hope everybody is aware of the existence, if not the detail, of things like the hierarchy of controls, that there are regulations for workplaces in Canada, standards exist, and of course we've covered respiratory protection programs in the previous session. Because this is a focus on pandemic requirements primarily, most of the presentation is around respirators at what we might say the lower end of the protection scale, where there's adequate oxygen in the air and we're dealing with particle filtration. But there's some coverage in here of other aspects for completeness. So we've covered respiratory protection programs, but overall, in this session today, we're covering fit testing in the next talk. And in this one, we'll cover a bit about selection guidance, correct use of respirators, and aspects of their use and maintenance, inspection, maintenance, and storage. There's a regulation in Ontario, and I appreciate some people are on the call from out of Ontario, but this is the Ontario link here, which is the sort of legal side of it. But by following guidance from the Canadian standard addressing respiratory protection programs, in Ontario, one will be in compliance with the regulations as well. Not to forget higher controls. We have the sort of classic one of elimination with substitution, engineering controls, and administrative controls, and with PPE, personal protective equipment, being the last link in the chain. That is the last resort when other means of avoiding the hazard have been exhausted. This in discussion around COVID has been sort of turned from a vertical hierarchy into a series of measures that all contribute to the protection of the individual from possibility of infection. And so rather than have them as a hierarchy, because of the different nature of a community disease, as it were, they are represented as different elements. And it's, again, more like a Swiss cheese model where each contributes, may have certain gaps, but each contributes to the overall protection. But personal protection there, again, is part of this method of overall insurance that the possibility of infection is minimized. First of all, we need to think about what is a respirator. Again, we've had a lot of discussion over the last couple of years, masks, respirators, masking programs, and so on. But really, when it comes to a respirator, as opposed to other things like, you might say, a face covering or in a relatively ineffective mask, respirators must offer a meaningful level of protection. And the general definition in Canada is that it is an item of equipment that is certified by recognized authority. Respirators offer different levels of protection, and this is sort of the can be thought of as a sort of ratio of the amount of contaminant outside the respirator to inside the face piece that's covering the area where you're inhaling. And this is sometimes expressed as a concentration of particles per cc, or mass per cubic centimeter, or parts per million of a gas. And this is something that's measurable. So in the top right diagram there, you have actually a measurement of the effectiveness of a surgical mask based on particles. It's about as effective by measuring that way as your hand over your mouth. And there are other methods that can measure gas concentration that are used in exposure determinations. And then we have fit test methods that rely also on the senses, the qualitative fit testing versus the quantitative. And again, that's something will be discussed. Just to mention, a surgical mask, although they are widely used, it's not a respirator. It lacks filtration and fit capability, and those are the two things that are important in respirator performance. The third one is function. So we talk about the 3 Fs in this sense for effective respirators: filtration, fit, and function. And these are the factors that all contribute to appropriate protection. If the material that it's made from does not effectively filter out particles, the product is going to be ineffective. If it filters out well, but still does not fit well to the face, there are problems because air will leak around and contamination will get into the breathing zone. And it's so difficult to wear that it impedes the ability for someone to do their job. The function side of it, if they can't be heard when they're talking well through such a product, or if they get too fatigued by wearing it and they're going to pull it off at the first opportunity, again, the overall protection they're achieving is impaired. And so these 3 Fs have to be in place. And we've actually heard talk of a 4th F, which is frequency. That is, it has to be worn, of course, as well to be effective. But you see here some of the issues concerning the terminology that you hear and the issues arising from these 3 areas. We talked about fit testing, fit checking, and so on, determining the fit, efficiency of the media, and you hear things like N95, where 95 is a % efficiency. And then we have the function to do with the airflow resistance, primarily, how hard it is to breathe through the item when it's worn. So these are the 3 factors that are important. So when thinking about acquiring equipment, you have to make sure that all of these are in place. The relative effectiveness is shown on this chart, and we see a scale at the bottom there, increasing effectiveness from left to right, both with capture and fit, or leakage in the descending order, going from the sort of popular face coverings, gaiters and cloth masks, through surgical masks, and those are to be modified with some kind of fitting brace, through to the respirator types, both fit tested and non-fit tested, through to elastomeric respirators, and each offering a generally higher level of protection. But again, it relates to filtration capability, the fit, and the ability to breathe through the product. I'll mention one thing as well at this stage, because the interesting thing has sort of arisen over the pandemic, and it's the fact that the laws of physics don't distinguish between living things and non-living things. That may seem obvious. It's probably a sort of science differentiation went out at the end of the 18th century. But in fact, we have had issues arising where even authorities like Health Canada having concerns that industrial respirators, as they call them, could not be used in healthcare facilities because there was some difference. In fact, there is no difference in the way the standards are written and in the way they function and the way they're tested. And so it is possible to use an approved filtering respirator that's intended for industry in healthcare. It was not going to have some deficiency when it comes to filtering biological particles. There are some specialized ones for healthcare that have extra testing done to them, but that's not a function of the filtration capability of them or the protective capability. It's the splash resistance. And so just to bear that in mind when you hear sometimes concerns that we couldn't use an industrial respirator, well, you could in fact. But there we go. Some of the respirators used in healthcare and other workplaces, you see some examples here. A common one is the filtering facepiece. These are disposable types, can be worn for several hours at a time. They may become soiled, they may become uncomfortable, and so they are changed out. But that's been one of the most popular types, also one of the easiest logistically, because they can be disposed of and replaced very, very quickly. Elastomeric face pieces offer a good seal to the face, and they come with replaceable filters. In general, the sort of loading that one gets on a filter working in healthcare or even in workplaces where you are only concerned with some of the infective material contamination, the loading they get is very low. And so you don't need to change filters very often in these cases. It's different from working in a mine or a smelter where there's a high level of dust, so that the filter change out is not that frequent. And so although they are technically replaceable, the actual cost effectiveness is rather high. Then there are two types called powered air purifying respirators. We have one with a half mask and one with a full head covering that are becoming increasingly popular in healthcare, but have been used in industry for a long time. These are rather more expensive, but they do offer more comfort and a higher level of protection, generally because air is being blown in by a fan of some kind, and then the expulsion of air around the periphery ensures protection. So these are examples, but the general guidance one would have if one is exposed to generally low levels of contamination is that the filtering face piece or elastomeric types would probably be adequate. But just to compare some of the costs, because you are continually replacing disposable face pieces, the cost just keeps on mounting. Whereas elastomeric respirators have a slightly higher initial cost, but over years will actually be rather more economical because the frequency of the filter change out is lower. Other parts may need changing out as well on occasion, but that's it's still quite economical. Powered air purifying respirators, yes, they have again a higher initial cost, but they do last a long time, and again give those benefits of greater comfort and what one might say better wear compliance. People are happy to wear them, and so overall leading to fewer infections in the workforce and community. And so yes, we may be dealing with things that are $1 or $2 or $3 on disposable side, but their use over time does really accelerate way above the use of other types of respirators, just to bear that in mind. To complete the picture, just to say we've talked about filtering face pieces, disposables, and simple elastomerics and powered air, but there are other types, full face powered air, full face negative pressure, and self-contained breathing apparatus types that are available, and they have increasing levels of protection, but also, as you see, increasing cost, and in some cases increasing physiological burden, that they are harder to wear. They impose more burden on the wearer, and increasing logistic complexity, that was obviously having to replace batteries and so on is slightly more complex, and having to charge and replace air tanks is even more complex. But so you really get a choice of protection, but at a cost in other areas. I say the general types are the left three are the ones that have been generally chosen for use in healthcare and other workplaces in response to COVID. But just to bear in mind these numbers called assigned protection factors, that's actually an allocation of the ratio that is acceptable for use with that equipment of the concentration of material outside to inside the respirator. And that comes up in some of the selection guidance later on. We bang on about approved as well. You hear a respirator must be approved. And there's a reason for wanting an approved respirator, because it's been through a special process testing that ensures it has good capability. It delivers a minimum high level of performance. And the authorities that do approvals, I'll get onto those in a minute, really are good at ensuring that they verify the paperwork from manufacturing plants to ensure that the quality control processes are suitable and are in place and records are kept. They do maintain the fact that a manufacturer cannot change a product once it's approved without having it retested or reevaluated in some way. So that you can't have perhaps a scrupulous manufacturer submitting one kind of sample to be tested for approval and then changing it for sale. It's all heavily controlled. It's also audited. The approval authorities visit manufacturing sites to audit them to ensure that there's ongoing compliance with the submitted information. And they even purchase samples anonymously, so that with testing of those, they're again verifying that the manufacturer hasn't made some change that compromises safety of the product. So just to bear that in mind, when you're considering approved versus non-approved, this is the benefit that comes with buying an approved product. One other point is that they cover a system, and that's less assurance for the user, but what it does mean is that you can't mix and match, say, filters on a face piece. In North America, the requirement is that you buy the same filters that are approved with the face piece initially. You may have a face piece that can take different filters. It may take different kinds of gas filters, different levels of efficiency of particle filters, but they must all have been approved in each case. So that's, again, the assurance, as I said at the start, we have a very high quality system that ensures that the performance of the equipment provided is highly capable, and the approval system is part of that. Historically, we've actually used the National Institute for Occupational Safety and Health in Canada as the main body for approving products. That was mainly because when legislation was set up, there were only US manufacturers providing to Canada. There are now a lot more Canadian manufacturers before the pandemic and, of course, during the pandemic. And there are marks to ensure that products are approved, so you know that the product you're getting is capable. But it has unfortunately led sometimes to less scrupulous companies wanting to make a product available that is not approved. And so there are various websites you can go to check on approved products and look up information on counterfeits. Mentioned historically, it has been NIOSH undertaking approvals, but in 2021, a system was set up so that the Canadian Standards Association now conducts approvals for use in Canada, a system that's in parallel with NIOSH. And the new standard has been generated, again, largely in parallel with the NIOSH standard, covering the performance of respirators in Canada. So you would have seen NIOSH approval on products historically. You now will see a CSA approval as time goes on, being increasingly available. Just to talk a little bit about counterfeits, there are sort of three levels one might observe of counterfeiting, or I say discrepancy rather than counterfeiting. Sometimes manufacturers make a misleading claim that this is an N95 product when it's not. They use N95 in the name of the product, and unfortunately there's no restriction on that, although that is now being trademarked, and that will in the future not be something that companies can do, but you will see this. In some cases, non-approved products are called N95s, even though they don't meet the actual N95 level of performance that NIOSH has, or they haven't been through the approval process. Some companies actually choose to reproduce approval information, even though the product is not approved. And others may, in fact, purport to be one company's product, another company's product, when they're not. So it may be the same color, same shape, same markings, but in fact, it's not that company's product. And that is much more complicated, of course. But companies, and 3M is one, that take extensive measures to ensure that the public is aware of these issues and to chase down those who are undertaking such a practice. And by the way, NIOSH does not approve products with ear loops or products for children. So if you see claims on such products that they are meeting N95 other requirements, it's not a NIOSH approved product. It is, again, a false claim. And so, yes, just to look for, I won't go into this in detail, but you would find markings on a respirator indicating information about the approval. This is from the CDC website, link there. So you can get the guidance on what to look for to ensure that the product you're buying is approved. And say this is not really normally part of selection, but because of the way the pandemic has driven things, that is something that we are considering. When it comes to selection around the hazard, a quick overview is that there are different things that drive selection of respirators. And that's the highest thing, in fact, is ensuring there's enough oxygen in the air to breathe, because you need special kinds of equipment to deal with that. A filter can't create oxygen, for instance. Then there are gas and vapor hazards have to be considered, because they need a special kind of filter compared with a particle hazard. Looking at particle hazards, and then there are other protection needs. Do eyes need protection as well, because something's perhaps corrosive or irritating? And of course, based on the exposure concentration, that drives the nature of the protective equipment that's needed. So these are sort of things that are, what you might say, in the mandatory state, that they are what really forces you in a particular path of choosing a kind of respirator. And then there are other factors that more relate to the workplace that may drive the decision as well. Can one obtain a fit with, well, the individual obtain a fit with a particular kind of respirator? That does determine what you select, of course. They must obtain fits to use the respirator, but that may drive decisions. If you may not be able to obtain fit with one level of respirator, it may mean they have to drive to a higher level of protection. And there's a choice around disposable or reusable, because in some cases that is, the same level of protection in the APF scale is offered by disposable or reusable types. And then there are issues around the workplace, looking at the user population, what sort of work's been going on, how comfortable different products are. Products of the same capability may have different levels of comfort, of course. Are they available? Logistics around supporting these. Again, it comes up sometimes with things like maintenance programs and battery use and so on. And now more consideration of environmental impact. Does the equipment have any kind of biodegradability if it's being disposed of frequently? And then the cost perhaps is the last thing that should be considered, but it is a factor in decisions, of course. So as I said, some are on the mandatory side are covered in protocols and standards, and the other side, workplace factors, are really what are the decisions of the employer or the workers combined in the workplace. On the mandatory side, there are regulations and standards that cover this, some other guidance sources one can go to. But on the worker side, it's really the user instructions, information from manufacturers and suppliers that you have to look at, and even trying out different kinds of equipment as well. And some manufacturers are very obliging in letting employers try out different kinds, and so they can select the best one they like. A Canadian standard has got a lot of information on the selection process, and this is partly what I'm referring to from now on. When it comes to selecting according to the hazard atmosphere, there are really three issues with the hazardous atmosphere. Oxygen deficiency, then there are gas and vapor hazards and particle hazards, as I mentioned. Within particle, it's kind of broken down into biological and non-biological. And of those biological ones, some don't really have a physiological effect, and some do have an adverse effect. Infection, of course, is one to consider. Irritation, allergies, and so on. With oxygen deficiency, you really are limited to certain specialized kinds of equipment, self-contained breathing apparatus, or an airline that takes air in from outside, or oxygen generation equipment. Gas and vapor, you need to follow a specific chemical selection guidance to choose a filter of appropriate capability and face pieces and so on of appropriate structure necessary to protect against the gas and vapor. And you may need a combined filter that can take out both gas, vapor, and particles. And there's a selection guidance to follow for that. And then for the biological side, there's actually biological aerosol selection guidance in the Canadian standard, and it's actually unique in the world in that. There are two sides of guidance to follow according to the hazard that exists. And the application is that atmosphere supplying respirators can really satisfy all need, but they have more of the cost and logistic issues. Filtering respirators cannot address oxygen deficiency, but can address other needs on the other side. So when it comes to the selection, a very brief overview. We have whole talks on this and whole day-long courses on this, but for chemicals, it really is based on the compound type and concentration. I don't suspect this is going to be necessary for many people, again, in dealing with pandemic-related issues, but there is a process to go through relating the concentration that's found in the workplace to identified exposure limits, and then choosing the appropriate level of protection based on that. And that's where those assigned protection factors for the equipment come back in. It guides you in the selection there. For the biological side, there's in fact been a protocol developed for selection based on control banding. So rather than being able to know everything you can about the biological agent concentrations and infectivities, a scale has been developed so that we have an assessment on a 1 to 4 basis, low, medium, high, very high, and so on, for the level of hazard from the pathogen itself, from the generation rate, is it from a sleeping patient or from an aerosol generating procedure, and so on, or steps in between, and on the ventilation rate. Again, is the exposure happening in relatively still air in a corridor, or is it being done in a surgical suite, say, on a medical side? And so there's a control banding method within the CSA standard that takes these inputs, and then as an output comes up with a protection level that relates back to the assigned protection factor for the advised equivalent. And so this is a method to follow for regular exposure in workplaces. In many cases, the guidance will come up with a level 1 for typical exposures, which is a filtering face piece or an elastomeric half mask. In some cases, it does go higher, though. So, but again, much more detail on that in the Canadian standard, and I'll dwell on that further now. When it comes to use and care of respirators, number of factors to consider. First of all, storage is important. There is guidance on packaging for appropriate storage conditions of temperature and humidity, and maybe keeping things out of sunlight and so on. So they should be abided with, because the shelf life, that's the next thing, which is often given, may not be applicable if the product has not been stored appropriately. Interestingly, the NAR standard does not require a shelf life, but the CSA standard is requiring one. And most manufacturers, in fact, do offer a shelf life, either as a date of manufacture and a stated time in years, say, or as a use by duration, or use by date. But again, it applies only when the product is unopened. Once you take a sort of respirator out of its packaging, there's no way the manufacturer can assess what you've done with it, and so the shelf life stops applying. You'll find on approved respirators on the packaging, there are things that are called cautions and limitations, which is guidance on what you really should take care about when using the respirator. These are generally in standard language, though manufacturers may add extra as well. And again, these are some of the precautions about ensuring that it's appropriate to use that kind of respirator in the exposure environment that's present. And then manufacturers will require or will provide instructions on how to check over the equipment before you don it. Pre-use inspection, and that really is down to the manufacturer and the specific design of the product. So can't really say much more about that, but it is something to bear in mind. And then we come into donning and doffing. Again, manufacturers provide guidelines, some available from CDC as well. But in use, they get questions over ensuring that the respirator, if you are, say, removing it part of the time during use, that it's not going to be exposed to contamination that can get on the inside and then potentially be taken in by the wearer. So there are protocols to follow and care to take. Don't just, if you're working in a dusty environment in a wood shop, say, don't just put the respirator down on the table where the wood dust is going to gather onto it. Make sure that if product is stored, it's isolated in some way from the contamination. Cleaning and disinfection, again, it's very much down to manufacturer guidance. Some manufacturers provide cleaning materials, and they will provide guidance on what is appropriate methods of cleaning and disinfection, and in some cases, inappropriate methods, or to avoid using too much in the way of corrosive or damaging agents that could actually impact the performance. And generally do not immerse filters in liquids. It doesn't do them any good of any kind of filter. Big question is, how, for a reusable respirator with changeable filters, how long can it be used? And generally, there's guidance that is available from manufacturers that you can provide information on exposure conditions and the breathing rate, and this is can be used then to advise on appropriate change-out schedules. Some items are changed daily, some just because of the, say, physical contamination that they may get. In some cases, there are designated substances and other areas where filter changing is mandated. But in many cases, you can go to a manufacturer's website for a gas vapor filter, and they have some kind of calculation formula there, system that can then provide you information on how long you can use a filter between changes according to exposure. And some products now are fitted with end of service life indicators, where there is technology that can actually change in accordance with the exposure of the filter to the contamination, and so give a visual indication of how much of the filter has been used and allow you to know when again to change the filter. So again, I'm very much, this is hard to say generically, it is very much a matter of following manufacturer guidance or the information that comes with the product. Last thing to consider here is consumables and spare parts. If one's embarking on a respirator program, particularly for reusables, the filters do require changes, so make sure there are spares on hand so that work isn't interrupted. And there are sometimes other parts, valves and gaskets and so on, that may need changing at different intervals as well, just through use. So ensure the stock on hand. Maintenance is a question. Some, again, products range from disposable or sometimes called maintenance free to things that are highly serviceable. Every part can be removed, but you need to make sure what is user serviceable and what isn't in the products. Again, from manufacturer guidance, some manufacturers have service centers where you can send product to be serviced, so that they will again take the product in, generally clean it, and then also change out those parts that need changing. And this is particularly applicable to powered air systems. Batteries can be, I guess, recovered that way, and air tank certification is necessary for self-contained breathing apparatus. For disposal and replacement, again, there's local guidance to follow on disposal. And if you're replacing a product because it's finally unserviceable, again, you need to take care that you're following appropriate selection guidance again in making sure that the product you're replacing it with is capable of doing the job. CCOHS has actually provided a very useful checklist for the respirator safety operations that you can link to. And so with that, thank you very much. And I guess we can take questions now or later on. Thanks.
Thanks, Simon. I think for because of the time,
Okay.
and I think the idea was to leave the questions to the
Okay,
end.
that's fine. Thanks.
So just thanks, for everyone's knowledge, for everyone's information. Simon also presented Mask Smart 1, and it was more for the public. And there's some information on there. What about masks for children? So when you go back and look at the other two webinars, make sure you look at Mask Smart 1, because as Zia put in the chat box, the amount of information that you put into your presentations, it's a great resource. So thanks very much. Okay, over to you, Anne-Marie.
Super. Thanks so much, Simon, for helping debunk and addressing a lot of the questions that have been in the public eye about costs and approvals and how to pick one. Sorry, did you have something to add?
Nope, that was it. Thanks.
Okay, well, thank you so much. And there
Sorry, ran
are
a bit long, but yes.
No, we appreciate your contribution, and there's many questions in the Q&A coming in, and we'll address those at the end of the presentation. So next up, I am delighted to introduce our next speaker, Lydia Renton. Lydia is no stranger to the field of occupational hygiene and safety. She's the current director of occupational health and safety services at a consulting firm called Blue Metric Environmental. Lydia's experience over the past 40 years has been through federal and provincial government. So she worked for Health Canada and Labour Canada, in addition to the Ontario Ministry of Labour in capacity of occupational hygienist. Lydia has a wealth of experience as well, and donates a lot of her time to various organizations such as the Canadian Registration Board of Occupational Hygiene, the American Industrial Hygiene Association, and she's also a current board member of Workplace Health Without Borders. So without further ado, I would like to welcome Lydia Renton.
You're muted, Lydia.
That would help. There we go. Okay, thank you so much, Marianne. And I'm really pleased to be following Simon because he's really given you a great overview on selection, care, and use of respirators, and he's addressed not only the fitted fitted face pieces, but also elastomerics, and gotten into a really good area of how do you select. I'm going to keep mine to a very specific topic just on fit testing and fit checks, which is really important. There we go. Which is really important in order to properly protect yourself. And the reason why we want respiratory protection is because of our human respiratory system. So again, without getting into a lot of detail, just wanted to show you this because we inhale air, through our nose and our mouth, and it goes down through the respiratory tract and into the lungs, which has branches called bronchioli and alveoli. And that's where the actual gas exchange happens. And oftentimes, that's also where some diseases can be caused, either through the thickening of that membrane or slowing down the exchange process. Things like fibers in the lungs due to asbestosis, or particles from silicosis and other diseases. So it's really important to understand why we're wearing respirators, and it's so that we can breathe properly, we can breathe longer, we can breathe the way that our lungs are supposed to function. So we need to protect our lungs. There's a large quantity of dust, and again, people talk about dust, they talk about particles, they talk about smoke, and I will differentiate. When we talk about dust, it's particles, it's smoke, it's fumes, things like welding fume, which are a very small particulate matter, aerosols, mist in the air. Usually it doesn't include things like gases and vapors and acids and oxygen deficient atmospheres. Because those are actually addressed by the respirators that Simon was speaking to. There's a whole selection process for the difference if you have only particles in the air, toxic particles in the air, or if you're concerned about specific gases or specific vapors or that oxygen deficient atmosphere. So it can, those can damage the lungs and also other parts of the body. Other organs such as the central nervous system, our liver, our kidneys, our skin, things like that. So when we're talking about, small airborne dust particles, gases, and vapors, they can reach down deep into the lungs, and that's really where we breathe. People go to work and then they come home, or sometimes they're working at home and they have some hobbies and they don't wear a respirator and they think, oh, that's a very transient exposure, which it may be, but it really depends on the dose can make the poison. And quantity and duration are also really important to prevent any kind of illness or occupational diseases. So sometimes you may feel okay now, but it's a long-term exposure or delayed. And sometimes it's months and sometimes it can be years. And so that's one of the reasons why whenever you're exposed to something that can damage your lungs, it's really important to consider respiratory protection. Now, Simon spoke of the certifying bodies for respirators. I'm mostly going to be addressing the kinds of respirators for fit testing and checks, which have to do with the airborne particulate matter. I could probably go on for a whole day on how do you test, how do you fit properly, how do you make sure that that particular respirator is the appropriate one for you. I've gone into workplaces sometimes where it's been the wrong respirator and people have a false sense of security that they're being protected. They've worn an organic vapor cartridge mask when they really need filtration against dusts or particulate matter, or the reverse has always been true. They put on something like an N95 and thought that that was protecting them against some organic vapors. So moving back towards what Simon spoke about and Z94.4, it's really important to select the right kind of respirator and to have it certified. NIOSH is typical what we will see, but as he pointed out, there's also Health Canada now has the CA designations. So a certification on the respirator is really important. And the reason for that is you don't want counterfeits, you don't want fraudulent. You really want to make sure that what you're putting on your face and what you expect to be protecting you is actually protecting you. Now, again, he touched on this, but these are really the N95s, and the P99s, the N100s, the CAN95s. They are designed to fit an adult face. And therefore, anybody who says there's any kind of certification for children at this point in time is misleading. So again, what is not a respirator? These are all either face masks. So on the upper left corner, that is more like a face mask, which you may, if you're mowing your lawn, perhaps. Then there are surgical masks. And again, they have a specific designation. Some of them do by ANSI, a level 1, 2, or 3, depending on what they're used for. And then again, there's gaiters and cloth masks, and those are really not respirators at all. So a respirator really has a defined makeup. There's a very specific criteria that a respirator must be fitted to the face, and that is one of the hallmarks around it. So even these surgical masks, and again, there is a time and place for a surgical mask. I'm going to say not in the time of COVID or aerosolized or airborne particulate matter, but they do, have a place to prevent droplets from the wearer spreading to others. One of the big differences for these surgical masks or face mask is an N95 or above will have an electrostatically charged filter material, which is one of the mechanisms that it will do to attract some of the particulate matter in the air. These are not designed to seal tightly. The air is going to leak around the edges. It's not that it's likely, but it's, how much is it going to leak? And Simon really showed a great graphic on the differences between a gaiter all the way up to having, an elastomeric respirator, and all in between what will actually, provide fitting and leakage and what a fit factor might be. So how does a respirator really work? Well, it removes the particles from the air. The picture right there actually has an exhalation valve, which I think before COVID, a lot of people would wear. I know I hid mine after COVID because, it was just not acceptable to go out in public with even an N95 with an exhalation valve because, people, the reason for the exhalation valve in industry anyway is to make it a little bit easier for the wearer to breathe out. So they're breathing in through the face filtering face piece and then exhaling out with an exhalation valve. So you do want a good seal between the face and the respirator, because then it forces that air to pass through that filter material, which is going to filter out those particles, which actually captures the dust in a number of different mechanisms in the interstitial spaces, the electrostatically charged material, in between the material itself, and therefore, why it has to fit so well the face to the respirator is that any kind of gap will allow that to be inhaled either through up around the eyes, through underneath the face piece, or underneath the chin. So there are some things that do affect fit. And what's really important is to know it. So sometimes glasses and goggles can sometimes affect the fit. Some people need to go to a full face respirator in industry because of this. Facial hair is definitely a factor, whether or not it's stubble, beards, mustache, sideburns, any hair at that point where the respirator seals to the face. The other things that can affect fit are weight loss and gain. Sometimes people have accidents which causes a change in facial structure, or if you suddenly wear dentures, there can be leakage in introduced, and therefore you need to be aware of those types of things. And again, maybe it's another size of respirator which will do it. I love this, which I took from CDC NIOSH, which shows, people say, oh, can I have a mustache at all? Can I have any facial hair? Well, there are several of these types of facial hair which actually can be used underneath a respirator. And one of my favorite is this lampshade one and the Zora version. Anyway, you can go onto the website and find that. It's a really great schematic to use in your program as what might be acceptable for facial hair. So in summary, breathing particles can harm your health. Certified respirator is important to filter out particles. Checking and fitting your respirator, which I'm about to get into right now, are really important. If your respirator is damaged, if it's dirty, if breathing becomes difficult, you need to replace it. And you need to make sure that you don't have any leaks. So your best friend, your respirator, how to use your respirator? Well, you have to know your respirator. You have to know the parts of it in order to make sure that you're wearing it properly. So for example, here are the components. The most important one is the filtering material itself, but it's not going to filter well unless it's put on your face properly. So there is a nose clip, which tends to be metal. There is the head strap, which needs to be placed properly. So often I see people just putting both straps behind their ears, where in fact, this one is relatively well worn. The lower strap should always be around your neck, and the upper one above your ear, and maybe even up to your hairline, midpoint. Some respirators do have an exhalation valve, and they should all have a certification marking which shows NIOSH approval, and as Simon was showing, the TC approval number. So those head straps also, a certified or an approved respirator will always have at least 2 head straps, or it will have 2 head straps. If you see that there's only one, it's usually not a NIOSH approved one. And it's actually designed not only to hold the respirator firmly on your face, but also to make sure that it's pulling in the right directions and places. So you need to check your respirator before use. So don't use it if the straps are broken, or if they're pulled off, if it's damaged, dirty, or if it's hard to breathe through. Get a new one. Changing your mask, again, if it's dirty, throw it away. These types of disposable respirators are not meant to be washed. So talking about respirator fit test, again, respirator fit tests need to be carried out by qualified persons. And a qualified person means not only knowledgeable on the respirators, but also the methodology that they're using. Whether or not it's qualitative or quantitative fit testing, they need to not only know the equipment or the instrumentation they're using, but how it works, how also it can fail to work properly, how to do some the checks on it, and then also if somebody isn't passing the fit test, what they can do to help the person actually fit. Is it just helping them to put it on better, showing them how to where the straps need to go, show them how the nose piece needs to fit, show them that one of the straps needs to go behind the neck, and then retest that, or sometimes go to a smaller size, or to a different model or a different brand. So what does a fit test actually do? It is used to assess whether that specific type, the exact model, and the exact size of respirator can adequately fit a specific individual. Most of these disposable type N95s, which I'm mostly going to speak about, come in a one size fits all, but there also are some small and large sizes available. So specifically, there's qualitative QLFT and quantitative QNFT types of fit testing. These are really well explained in the CSA standard 94.4 that Simon referred to. But there is a big difference, and there's an advantages and disadvantages to both. First of all, qualitative is less expensive, and it's quicker. Well, it's not necessarily quicker to do, but it's cheaper, and instrumentation is really usually just a challenge agent and possibly a hood. But it does rely on wearer response to an odor, to a taste, to nasal irritation. Quantitative fit testing involves an instrument, which there is less wearer response. It doesn't rely on that. It responds to the difference in the particulate matter inside versus outside the respirator itself. And the testing is computerized, and it gives you a fit factor, and it tells you whether or not you pass or fail. Specifically around qualitative fit testing, there's 4 kinds of challenge agents. One is banana oil or isoamyl acetate, sodium saccharin, Vitrix, or irritant smoke. Now, irritant smoke is usually not recommended for a number of reasons because it's stannous chloride, and it really can be highly irritating to individuals. So when this is an example, the individual wears a hood and there's a nebulizer, and they introduce that into the breathing zone of the person. So the pass or the fail relies on that individual's voluntary or involuntary response, either, oh, that's sweet, or bitter, or coughing, or, based on taste, smell, or irritation. And if they detect this challenge agent, then they fail the test. When they do pass that fit test, they're deemed to have a fit factor that's at least as high as qualitative design, and that's typically 100. So here's an example of a quantitative fit test called the Port-A-Count. And there is another QuantiFit available also. They rely on slightly different principles. Again, in order to become competent to use such instrumentation, you need to be properly trained as to how it works, what actually is fitting, how you set it up in an individual, and then it actually requires the test subject to put on a probed fit face piece, and then they do a series of exercises with various workplace motions. So it's not just standing there, do you smell something? No, it goes through usually about 30-second exercises of normal breathing, deep breathing, head moving side to side, head moving up and down, talking out loud, that's reading the Rainbow Passage usually, grimacing, bending and touching your toes. So normal things that you might do in the workplace. And then it computes as a weighted average of all these individual fit factors, which gives you that in order to determine whether or not that's a good respirator for you. So to be fair, respirator leakage is a reality. There are some respirators that fit on, I would say most respirators fit on 80% of people, but there are a number of reasons why standard respirators don't. And that's because typically we have, it's the shape of your nose sometimes, how it sits on the nose, that it has, people have not actually put the straps in place properly, or that they haven't used the nose clip. And therefore, when you do a proper fit test, you're also making sure that the person demonstrates their ability to put it on and off, and that you're selecting that respirator most suitable. So you may try a different brand, which gives you a higher fit factor, and that person can then go ahead and use it. Now, again, there's a lot of workplaces who don't necessarily have access to this expensive instrumentation or have the knowledge, but there are suppliers out there who can help do this for you. There are consultants out there who can help you. What I would love to see is, community-based fit testing where individuals can go in and, can get fit tested on a respirator. And again, we may be at this point in time far from that, because you do end up using up a respirator because it needs to be probed while you're doing the fit testing. Another very important component is checking your respirator. So you may be fitted on it, and you put it on your face. But how do you check? You know, you had it fit tested a week ago or a month ago. How do you know that it is still okay? So, you know that this is the brand, this is the model. You're taking it out of the packaging. Your hand should be clean. Don't touch the inside of the mask if at all possible. So you need to put it on your face. You open up any flaps if there are any, or you take it out of the bag, but you prepare and you actually place the mask over your nose and your mouth first, like so. And then you fit the straps to the head, one behind the neck and the other one around the top of your head. There's so often, I can't believe how many times, even right now, people are using N95s, which they didn't even know existed before COVID. So, I mean, one thing that COVID has done is brought to the forefront people's knowledge around what is a face mask versus what is a respirator. And hopefully also, they need to read the instructions on how to put it properly on their face so that it actually is going to fit properly. So once your straps are on, you make sure the lower ones behind your ears, you stretch them and you make that seal. So as you can see, this particular one has an exhalation valve. Simon already showed how if there's one with no exhalation valve, you essentially put your hands over the face piece. But before you've done that, you really need to make sure the nose clip fits well. So you gently press it with 2 fingers on both sides of your nose, so it fits well across your nose and onto your face below your eyes. You don't pinch the clip. And then, so you're shaping the nose clip, if you want to call it that. Now, this is the important part, the fit check, which is much easier to do on an elastomeric half-face respirator because they actually have an exhalation and an inhalation port. But these still is possible to do it on an N95 with or without an exhalation valve. So Simon showed a picture where you just put your hands right over the whole face piece and you gently blow out, and you want to make sure that it's not popping off your face, or you breathe in and you want to make sure that there's a little bit of cupping on your face. And that way you're checking for any air leakages, around either, your eyes, your chin, and your cheeks. And then you adjust it if there are leaks, and then you do this all over again. So to summarize, always use a clean, intact, functional respirator. Replace it as necessary. Don't share them. Verify your respirator. When you're in a dusty or an area where you believe there's either particulate matter, smoke, mist, fumes, or biological hazards, wear it 100% of the time. As soon as you take it off, you're not protected anymore. Know how to fit it if you can. Get an appropriate qualitative or quantitative fit test, and then check for that leakage every single time you use it. So again, leakage is a reality. You want to know, was there really exposure? And that gets into a whole other side of exposure, worker exposure monitoring, to see whether or not you actually are protected, and against what, and what might those airborne concentrations be outside your respirator that you need to be protected against. That is not being covered here today. When to you need to know when to wear a respirator, and have a respirator protection program, which was covered in Mask Smart 2. When was your last fit test? CSA standard says at least every 2 years, or if there's changes to your weight gain, loss, other factors. And you need a separate fit test for every respirator that is worn. So what is really important is read those instructions from the manufacturer, get the training on selecting the proper respirator, make sure it's used properly, make sure not only yourself, but also if you're overseeing or if you're even starting up a respirator program. And if in doubt, seek out some help. There's a lot of people within the coalition and with OHAO who can definitely help you. And I'd like to thank you for your attention. And we'll be taking questions at the end of the presentation. So I'm going to pass it back to Anne-Marie and Kevin.
Thanks so much, Lydia. And just for everybody's benefit who doesn't know Lydia, because I know we've got quite a few non-hygienists on the webinar. Lydia has a wealth of experience and some really good practical, information too. So just so everybody knows that, we really want to share the best information that we can get hold of. So thanks, Lydia. Just for the sake of time, we haven't really got a lot of time left. I think we've only got 22 minutes, and I really want to kind of get Dan to speak. So just a quick introduction. Dan Curts has been involved in occupational health and safety for over 40 years. He is currently employed at 3M Canada, London, as Senior Advanced Applications Specialist in the Personal Safety Division. Previously, Dan was employed by the Ontario Ministry of Labour as an occupational hygienist for 12 years, and at IBM Canada as an industrial hygienist for additional 5 years. Dan has developed and continues to deliver a number of credited courses related to health and safety, has been for over 34 years at the University of Western Ontario and Humber, Fanshawe and Lambton colleges. Dan is certified by the American Board of Industrial Hygienists, the Canadian Registration Board of Occupational Hygienists, and the Canadian Board of Registered Safety Professionals. Thanks so much, Dan. Over to you.
Thanks, Kevin. And Lydia and also Simon, thanks for also setting it up nicely for me to wrap this up. So I'm going to share my screen here. And we'll go quickly. There we go. And I think we can all see my screen now. Yes.
Okay.
Good. All right, fine. Thought I'd start with a little fun. So this is kind of my family and stuff that like to do. So up in the upper right-hand corner, I have a very large family. It's grown over the years and it continues to grow, and I love them all. So we like to do a lot of stuff in the summer, whether it's on the water or at a cottage, and certainly enjoy that. So now I'll get right into the presentation here. So I'm going to talk about lessons learned from COVID-19. And there certainly are a lot of lessons. I'm only going to look at them from a relatively high level standpoint. So as I start, I have to put this up because I do work for 3M, as Kevin had mentioned. And our lawyers, which we have many, insist on this being here. So there it is. And now that I've shown it, I can move on to the actual part that you're interested in. I think the first lesson that I hope we have all learned is that we need to rely on good science. And good science is critical, but it's often not found in the media. And I think if I look back, and I'm sure you're probably many of you are in the same situation, you were probably bombarded with questions related to COVID-19, how to prevent either yourself or your colleagues from contracting this virus. And they often looked to the paper or to the media to give them the information that they were using to support their decisions. Unfortunately, I think it's important that we also look at the media, but look at it from a much more critical standpoint. And I don't want to, belittle what the media is doing. They have a job to do, and they do it as well as they can. Often, the information that they're getting is perhaps somewhat sensationalized. So we need to take that and understand it, but look to the sources where there's some good science. And I would say things like what's already been mentioned, the CDC is quite a good area to look for. There's some other areas too, like CIDRAP, and I'm using some short forms here, but if you go on and talk to some of your colleagues, or talk to Lydia, talk to Simon, talk to myself, Kevin, or Anne-Marie, we can help you out with some good sources of science information related to COVID-19. I have a picture here, and I think it's been discussed both last week as well as, again, Lydia in particular mentioned today. There was a lot of concern about masks and respirators, and were they the same, were they different? If you were wearing a mask, wasn't that adequate? And I think just from what Lydia has already pointed out, there is a significant difference. And the one was actually designed as a source control. And the source control is basically to ensure that when you sneeze or cough, or these big sputum particles are, shot forth from out of your respiratory system, they're somewhat blocked by the mask or the mask material that's on the person's face. There's all kinds, as again Lydia pointed out, all kinds of different styles, whether they be gaiters or the one that's in the picture. There's a lot of good out of these masks, but unfortunately one of the things that is not so good is that it's led to a lot of confusion around what's a respirator and aren't they the same. And again, they are not the same. The respirator was always designed to protect the user. So from an inhalation standpoint, if it's a biological agent or if it's a particulate, that would be either a solid or a liquid. Again, if it's fitted properly, then it will protect the wearer of that respirator. That's not necessarily the case with a mask or barrier face covering, as they are now somewhat called, to help distinguish the difference between a mask and a respirator. All right, so I think that's an important lesson that we've learned. I think another one is that you are important because you are the translator of what is health and safety. And what you actually say really does matter. People, whether they be in your company or people outside the general public, they're looking for experts to help them better understand so they know how to protect themselves. And so when you're in a position of authority, you understand the science, then it's important that you speak well, speak clear, speak in language that they can understand. And it's too easy, and I'm one that has this problem periodically where I'll speak in the jargon that occupational hygienists often fall into. And that's fine if I'm with other occupational hygienists, but it's sure not fine when I'm with the general public. I'd say the one that helps correct me the most often in that is my wife. She simply says, "Hey, come on, what are you talking about?" And that's fair. Use the language that they're going to understand. And what you do say about COVID and how to protect people really does matter. I think one of the other lessons that we learned was things change, and they were changing very rapidly. The information related to COVID-19 was not well understood. To a point, it's still not well understood. And I'd like to think that, we're over COVID-19, but I don't think COVID-19 is over us. And I'll show you in the next slide, I'll show you what I mean by that. So as change happens, I think it's important that we embrace these changes. Understand the science that goes along with these changes, whether it be the change, a new variant comes along, and we've certainly seen the Delta variant and what it did, and then the Omicron one, and now we're into the BA4 and the BA5 and the BA 2.1. Well, these are going to continue to mutate, to change, and to create more concern. Understand them, make sure that you are able to communicate what these changes mean to help, again, people protect themselves as well as their colleagues and their and workers that you're responsible for. The last one is kind of, it's a call to action. It's to be prepared for the future. You know, we all seen that there was a shortage of respiratory protection, not just in Canada, but abroad. I think every country, there wasn't near enough supply of the respirators that were deemed necessary. And so now that there's kind of a lull within the COVID-19 experience, it would be a very wise idea to begin to think about how many respirators do I need? How many do I need to have on hand in order to protect people, but also to ensure that you have business continuity, that you can continue to make whatever it is that you make. And I don't think we do necessarily a good enough job. I mean, I would say the next question is, well, how many do I actually need? The CDC, and again, very reputable, has a tool that is free. You can go on their website, type in pandemic stockpiling, and there is a series of questions that they will ask. You can do it for a department, you can do it for a location, you can do it for multiple locations. And as you go through and you work through these questions, they're not difficult, but it is adding to their calculation as to how many you need. And once you have that, then you can figure out, okay, well, do I want to be 20% ready for the next pandemic? Do I want to be 50% ready? Do I want to be 100% ready? Now, there's always a cost with this. And so one of the things I would say is that with the costs, if you can take the materials, take the respirators that you put in stock and rotate your stock. And this is, again, very simple stuff. This is what stores do all the time. They take their older stock, they move it to the front of the shelf, they take the new stuff, they put it to the back of the shelf. Well, if you're using respirators at your location currently, well, use the older stock, put the newer stock at the back, and then keep working that through. It just makes good financial sense to do that rather than take all the new material, put it all in a big warehouse, and wait until the next pandemic happens, or epidemic, or natural disaster where you need respirators. So that's my words of wisdom. Get prepared. And when you do that, and you know, to Neil's point last week or last seminar, update your respiratory protection program. Include the information that you've now learned. Put that in there to make it more robust. And the CSA standard, the Z94.4, talks about all the elements, which again, Neil went through last week and Paul did too. But I think in addition to that, which is a requirement to update annually, I think if you have more information, you should update it more frequently. Keep it as current as you can. And I mentioned in the last, this is the end, COVID-19 is not going away. I'd like to think it is, and I think most of us would hope that. But I pulled this table out again from the US. But I think it shows a very interesting trend, and not necessarily one that we want to acknowledge, but we have a lot of pandemics starting in the Middle Ages, where we had somewhat good records and ongoing. And if we just look in the last 20 years, we've had 4. There's 2 that are still ongoing. And I would say somewhat even the swine flu is still around. These things don't go away. They mutate, they change. There are different variants. So we need to be able to step up, understand, take the right precautions. But I think that we need to also get prepared for the next, whether it be an epidemic or a pandemic. We need to get prepared again. Let's not get caught off guard as we were in this COVID-19 situation. And I think that's it for my part, to try to catch us back up on time.
Thank you so much, Dan, for your lessons learned with respect to respiratory protection. Now for this part of the program, we are going to go through the list of questions that we have received through the Q&A. Some of them have been answered with the typed in answer by some of our panelists. If we do not get to your question, I do encourage you to reach out to OHAO or the Aerosol Transmission Coalition's websites, which we will relink in the chat. So Kevin and I, we're going to go through as many questions as we can, mindful of the time. You know, it is possible that we might go to 1:35. So let's get to it. So one participant has asked, when wearing an elastomeric respirator, is it still effective once your face starts sweating and it gets slippery around the edges? This happens to me after about an hour or so. I've noticed that when I exhale, once that happens, the air seems to leak out around the edges. What's recommended when this happens? Who'd like to take this? Perhaps Lydia? Smiling there.
Yeah, I'll start to take it. That's an interesting one because sometimes, and again, you're saying elastomeric, if it's silicone based, sometimes getting a little wet actually gives it a better fit onto your face. So you probably must be like sweating quite profusely in order for there to be a gap and for you to physically feel that infiltration on it. It may be a number of things. I would go back to checking the fit on that. You know, it may be slightly too big, slightly too small. I'm not sure.
Lydia, to your point, and you did a great job of presenting it, do a fit check. Again, a fit check is not the same as a fit test. So if you feel that respirator moving around on your face, well, check it. And if it is leaking, well, remove yourself from that area, wipe down the area on the face as well as the face piece, re-don, and then again, do another fit check and then continue on with your work.
Yeah. And just to add to that, I know in the past, I don't know if the practice still happens, but people used to sometimes think that they get a better fit if they put some Vaseline on the edges of it. Like a respirator is not meant to add anything to it. You know, you wear it directly onto the skin. So, but do what Dan suggests is that, you know, giving it a good wipe down too, and the check.
Super, thank you. Kevin, you're muted.
Yep, thanks, Lydia. And I just want to kind of relate back to the question with Eileen Chan, and you know, well-known infectious disease specialist in Canada that's, you know, got a lot of attention, has talked about acne. You know, respirators causing or you know, affecting acne. But Eileen Chan says, are there disposable and reusable respirators that are latex free? And to my knowledge, you know, you think about the gloves, the old latex gloves that we use in hospitals, the powder and the gloves cause latex allergies, but I'm not familiar of any respirators that would cause any kind of latex allergy. I'm just wondering, is that right, that what I've just said?
I'll start, and I'll say I'm not aware of respirators being made from latex. And again, as you would probably know, there's about 18–20% of the population who do have some kind of an allergic reaction to latex. So that is typically not used. But there may be something else, you know, going on, you know, some kind of other type of irritation, more than an allergy directly on the skin. And again, it depends on the type of skin condition. I would certainly, if it goes to the extreme, I would find out from a dermatologist what that might be. There's not just a straight answer without knowing more details.
Thanks, Lydia.
I'll add maybe a little bit more to that too. And I also see Dorothy's asked about the straps and whether they might contain latex. Go back to the manufacturer of the product that you're either using or going to buy. Ask them directly, or go to their website and look. And it was mentioned, yes, I work for 3M. We don't produce any respirator that has latex in it. And we're pretty upfront about that. It's right on the website. You can check out each one of the products. And that's one of the reasons why, is because of the number of people that do have latex allergies. So go back to the manufacturer, check it out. And that would include the straps, Dorothy, of which there are many different types of materials that can be used for straps. So it depends on the model of the respirator that is actually being used.
Okay,
Thanks.
great. On to another great question. This was answered, but I think it's a great one for discussion. Is fit testing required for the workplace for voluntary use, or just nice to have?
Great question.
That is a great question.
I'm going to get you to answer that one first.
So, it really, I mean, from my perspective, it really depends on the jurisdiction that you're in and what the occupational health and safety laws call for. As an example, in Ontario, under the Regulation 833, when respiratory protection is provided because the employer has identified the hazard, yes, that falls under the requirements of having a respiratory protection program. And there are prescribed requirements for that, which would include fit testing. Now, something that is taken on by an employee on their own accord, in my opinion, as a best practice, yes, you still want to be fit tested, because otherwise you're not going to know whether or not it's providing the protection that you are hoping for.
Mm-hmm. And you're 100% correct in that, Anne-Marie. And I think, you know, those companies who would have, you know, a respiratory protection program, if somebody, you know, on a voluntary basis wants a respirator, you know, the right thing to do is to fit test them. And then also make sure that the one that they're using is appropriate, like find out the reason. Why do they want to wear it? For what parts of the work do they want to wear it? And again, is it the appropriate filter or cartridge or combination against the contaminant of concern? I know in the US, OSHA actually says that, you know, if there is a respirator in the workplace, they must be, you know, fit tested, where there is a little bit more ambiguity up here. And again, it's very provincially based here in Canada, what the exact requirements are.
A good question that we should keep for our next symposium and put it to the Ministry of Labor here in Ontario as to how they approach very discretionary. So,
I mean, you could take it another step, you know, in my opinion. I went to the dentist, you know, halfway through the pandemic, and the technician was wearing a N95. And I asked her if she'd been fit tested, and she said, no, I'm getting fit tested next week. Now, would I say, no, you're not wearing that respirator because you're not fit tested, or yeah, keep wearing it, it's a good idea. Getting fit tested is a good idea. You wouldn't take a respirator off somebody if they're not fit tested, one. And two, a respirator is by far better than a surgical mask. So, you know, fit testing is really the end goal. That's my opinion.
Yeah, and I love, I mean, I'd reference the slide that Simon had that really showed the various fit factors right from the gaiters all the way up to an N95 and higher. And even what was great to see was that even an unfitted N95 definitely has a better fit than anything else. But of course, it would be lower than if you'd had a specific respirator fitted, because that, you know, that model, the make is fitted to you. So you're absolutely right, Kevin, is that I wouldn't pull it off the person's face, but I definitely encourage them to get to make sure that they get the training and get the fit testing for the respirator.
And I just refer to a thing that just came through the chat box in Ontario. This is from Yasemin Saraf. In Ontario, when COVID emergency measures were enacted by the province, the director sent to public organisations, school boards and healthcare that N95 respirators can be provided without a fit test, and the user should be fit tested as soon as reasonably possible. We kind of like that. I just want to add to that too. When I was in Queensland, Australia, if you think about the Australian Institute of Occupational Hygienists, for example, they have a RespFit program, an accreditation program for fit testers to make sure it's done properly. It's a specialized skill, and needs to be competent to do that. And I was based in central Queensland, and I hadn't really, even though I was a hygienist, I hadn't really been trained in fit testing, even though it's something you could look at the manual and kind of work your way through it. So at that time, 3M were kind enough to come to the site and actually provide fit testing as part of the service. So, they had trained fit testers that could do that. And I'm not sure if that's something that could happen here in Canada, but I just thought I'd throw that on the table as well.
Yeah, I'm aware that there are a couple of distributors that if you buy your respirator from them, they will come and do some training and fit testing for you. So that's always good to find.
Super. Now, I think we have time for one more question. This might be appropriate for Dan. How long can respirators be kept if stored in their packaging? So unused. Can you ignore the manufacturer's recommendation? In circumstances when, stores don't rotate it through and you have an old but unused set in visually perfect condition.
Right. Well, so there's two questions built into that. The first one is how long can they be used? And the manufacturer, Simon has pointed out in his presentation, sets the amount of time. Normally it's 5 years in the original packaging. So if it's unopened, unused, and it's stored properly. Again, if you set it outside and you have a lot of UV, for instance, hitting it, or if you store it in a super hot area or super cold area, the efficiency may very well degrade over time. So in the original packaging, it's 5 years. Then the second question was, well, can you ignore what the manufacturer says? And I suppose anybody can ignore anything. The question is, how effective would it be after that? And that's a great question. I don't know the answer to that. So I wouldn't ever suggest you do that. But that's certainly, I guess you can do anything you'd like.
Yeah, I'm going to add to that just because very early in the pandemic, I had a similar question asked, and I reached out to Dan for the answer, and that was because somebody had a stockpile, and if it was, let's just say it was March 2020, they showed the date as being good until January 2020, and they were just going to toss all these when there was a scarcity at the beginning of COVID, and so to say, oh, they're no good, nobody was going to say that, and we knew where they were stored. They were stored properly, indoors, away from the sun, and actually one thing that we talked through was those would have been the perfect type of respirators to use for fit testing, because you'd have to probe them and then throw them away anyway. So they weren't for use, but there was nothing wrong with them, and they could have been used to do fit testing. Just a suggestion.
Even
Simon,
I think we've kind of we did provide 5 minutes extra, and I'm just wondering, what do you think, Anne-Marie? I think we probably, a lot of people have their own time.
Yeah, I think we are going to have to wrap this up, unfortunately, though I know we could have a multi-day presentation about everything that we've spoken about today. On that note, I would like to thank Dan, Lydia, and Simon for sharing their time with us, and to the participants for joining us today.